Hello everyone, in this video I would like to introduce how we can set up the Ethernet IP communication between the Allen-Bradley compact logic and Keyence IV2 camera sensor. Before we go to the Rockwell Allen-Bradley 5000 or Studio 5000, go to the PLC programming wise, let's go to find out some important material from Keyence IV2 area. Firstly, let's go to keyence.com products vision sensor and find out IV2. And once we reach this page, let's go to the software and manuals. To set up the Ethernet IP communication between the PLC and the IV2, so you can download a very important user manual, Field Network. It introduces the detailed setting. Also, it has a specific manual for the IV2 Rockwell Control Logics Connection Guide. And in this video, I will use compact logics. And also, based on the previous video, I introduced how we can set up the sequence structure in Rockwell RS5000 or Studio 5000, set up the sequence structure. And in this video, I will use that sequence structure to program how we can trigger, how we can register the IV2 camera result. And meanwhile, we also need to go to the software and download the EDS file. It also have this IV2 tag file for Ethernet IP. As we know, to use the PLC to communicate with the IV2 camera sensor by using Ethernet IP, we do need a EDS file as well as this tag list. So we know which signal is a trigger, which signal is a feedback signal. For example, busy signal, result update complete, the trigger, the sensor busy signal, or the ready signal. So we do need this tag list. And regarding the EDS file, let's scroll down and download this IV2 setting file for Ethernet IP network EDS file. And in this video, my logic is not the same as this example program. That's because I'm trying to use the structure, use a common way, use the structure logic to trigger or register the camera result. It's more reliable, and because I used this structure for multiple projects, they used in the actual cases and the projects. So I think they are very reliable. So I would like to share my structure. Scroll down, find out this IV2 series user manual control panel. And let's also download this manual. And because there's one timing chart I would like to show for you. And let's go to the chapter 10. In the chapter 10, this section 1, controlling timing of judgment with the triggers. So this timing chart is very important. I will explain after. Okay. And in this video, I will use one actual controller L32E version 20 and the software that is a Rockwell Allen-Bradley RS Logic 5000 version 20. And in the previous video, I set up this sequence structure, and I will use this sequence structure as our base and program the trigger and camera register logic. And firstly, let's install the EDS file. I already downloaded this EDS file, that's the IV2 EDS, and version that is 1.0. And file name is this. Firstly, let's go to the tools, EDS hardware installation tool, and install this EDS file. So let's click the next and register an EDS file. And from this browse, let's go to find out the file we just download. Okay, we find out this file, Keyence 4605, this file, that is the IV2 EDS file. Open. Next. So it installed. Icon, IV2 series, let's remember this name. Click finish. So now let's go to the network area. My controller, that is L32E, it has one built-in Ethernet IP port. So come here, let me right click, click new add module. And come here, let's search IV2. Okay, it show up. This IV2. Click OK, add new, create. Okay. So the name, let's name it IV2 camera. Okay, and IP address, I will type in its IP address is 192.168.1.101. That's my camera IP address. So we click OK. Alright, we create this Ethernet IP device. Let's go to the controller tags, and we will see this is IV2 camera. So it only has this connection faulted. It doesn't show up the input and output. That means this EDS file has something wrong. Alternative way, we can manually set up the generic connection here. We need to manually type in the assembly input and output. So this EDS file, by some reason, it doesn't work. So I will delete it, manually create that generic connection. So let me delete and connect the new module again. And this time, let me type in generic. So let's use this EtherNet module, generic EtherNet module. Okay, let's create. And IP address this time is 192.168.1.101, same thing. And name, that is IV2 camera. Okay, and now it show up here, the common format data, that is a DENT or int. And what the input output configuration number we need to type in. Regarding this, we need to check out the menu we download. Firstly, let's check out this IV2 series users menu field network, and then go to find out the chapter 3 cyclic communication, and go to find out the PLC setting Rockwell automation control logic series setting. And from this page, we will find for the input, output, and the configuration. So here, input, we need to type in 100, output, type in 101, and the configuration, we need to type in 1. Okay, and the input size, that is a 196, and output, that size is a 6, based on the integer. And the detail tag, if you recall, I just introduced. So when you download this IV2 tags, it will provide you int and the DENT, two files. So personally, I will prefer use this int DENT. So that means when we set up the format based on the int, so we need to follow this way, follow this address, set up the text name. So the format will based on this int. Okay. So at here, let's firstly select this data int. Okay, this input, I will type in 100, and the length, that is 196. This is integer. And output, that is 101, and the integer length, that is 6 integer. And this configuration, I will type in 1. Okay. And IP address 1.101. Common format based on the integer. Okay, let's click. So once we click set up this connection, so it will pop up this what we need, the input and output. It will create 196 integer length at here. And output, it will create 6 integer at here. And if you recall, so this is the detail address, and this is the tag name. To join those tag name and this address together, most of the cases we will use the COP copy. We will firstly create the UDT structure and create the tags based on this structure, and then use the COP copy and copy the input to this tag structure, and copy that structure to the output based on the output text list. All right, let's go to define the date type. At this user define, let's create the new date type. And at here, the name, we will create UD, the camera 2 PLC. This is IV2 input 2 PLC. Okay, And let's create a name at here. So we need to manually create this tag list at here. So the address name 0.0 is here, input 0_00. That is a trigger response, feedback signal from sensor to PLC. And regarding the output, so let me scroll down. So the first one, that is a trigger request. So I create this user-defined UDT IV2 PLC2 camera. So the first one, that's the trigger request. So the first one, the trigger request. Second one, master registration request. So follow this way, create this whole list here. And keep in mind, if you need a PLC to switch the program number, so when you create this programming number here, and this is one integer number at here. So if we scroll down, and when we create this programming number, this is a programming number setting, so that is one integer. After we create this two structure, using this tag list, we can set up the actual tag based on this user-defined structure. So let's go to the controller tags and create, firstly, let's create the IV2 PLC. Okay, the structure, we will use this structure, UD camera to PLC. Okay, once we create this tag, you will see all the tags are here. This is the input. And regarding the output, I will name IV2 PLC2 camera. Okay, so that structure, we will use this IV2 PLC2 camera. That is the output from PLC to camera. Okay, we will select this one, PLC to camera. So we can expand that. So we will see the trigger signal is at here. Okay. And now those two structure tags are internal tags, and the actual input tags from the camera is this, and output signal is this. So how we can connect them together? So we need to use the COP command. So let's firstly go to main. And if we go to the main, if we assume our camera program will be programmed inside this sequence demo control, this routine. So before this routine, we need to load the actual input signal into our internal tag. That means here we need to add one run. Move this run here, and we need to use the COP command. And the source, that will be the input. The actual input, IV2 camera. This is the actual input, come from the generic EtherNet IP file here. Okay. And here we will use .data. We start from the 0 because this is a one array signal. And the destination, that is our internal tag we just created. And that tag, that is IV2 camera to PLC. So that comes from this structure here. And the length is 1. We copy this entire things, copy from here to there. And double check the length they are matched. So the entire length, that is 392 bytes. Okay, this is the input. After this, we need to use another copy. Copy the internal tag to the output tag. So the source, that will be the PLC2 camera. And output, that is this. The IV2 come from the Ethernet IP generic file here. The output and the data. So we start from 0. And because the output from PLC to camera, it has a 6 integer. So here the length, we need to type in 6. It has a 12 bytes, 6 integer. So this length, we need to type in the 6. So this length represent the destination length. So let's rename this routine. Properties, I will rename it the IV2 IV2 camera. Okay. So this is the input, and this is the call the IV2 camera routine, and this is the output. Okay, let's go to this routine. And based on this routine structure, so we will involve the actual IV2 camera signals. So the first step, we still probably need this part present and sequence start. The part present could come from the sensor, and once the sensor detects the part present, we can start the IV2 camera trigger signal sequence, right? Other than this, we need to involve some other signals because this is the initial status. So we need to read the IV2 camera to PLC. We need to check out if the camera is in a running mode. So let's find out if the camera in running mode. Okay, in run. And also this camera, if this camera is ready, and this camera also is not busy. So if the camera not busy and is ready and in run mode, and once we start, so we start this sequence, right? And how we can use this sequence to trigger the camera, we need to check out the timing chart. And now we need to review the menu. IV2 series user menu control panel, this menu, and find out the chapter 10. From this chapter 10, controlling timing of judgment with triggers. So this timing chart is very important. And to use a sequence to program this trigger and the results register. And based on the timing chart, we can separate this entire timing chart into different steps. At the beginning, we start from 0. And once the sensor got ready, once the IV2 camera got ready, so we can trigger. And once part present and the sensor is ready, so we can trigger this camera. So the step, that time is at 1. And once the camera receives this trigger signal and shift its internal status to busy signal, to busy status, so that time we shift 1 to number 5. At that moment, we can turn off that trigger signal because the camera already received that trigger signal. And after this, we are waiting for the camera processing the image. And once the busy signal from camera shift from 1 to 0, that means the entire processing is done. At that moment, we can shift the current step 5 to step 10 using this busy off signal. And at this step 10, we can register the result. And after this register, so we can shift to the 15th step. Basically, at 15, that entire trigger and register step are complete. So let's follow this step number design and go to program. So at the beginning, when the part present and the camera is in run mode and is ready, not busy, so we can shift to the step number 1. At this step number 1, here, we can trigger the camera. So that means at this step, we can add a line here. That is the trigger signal to the camera. So we can use the IV2 PLC to camera. So at here, we can trigger the camera. And this trigger will turn on. If the step number at 1, so this trigger signal will be on. When this step will move to the next step, when it will turn off. According to this timing chart, we will wait for the busy signal turn on from 0 to on. That means once we receive the busy signal to on, so this sequence condition will turn on. Allows this sequence move to the next step. Move from step 1 to step 5. That means the busy signal will be used to control this sequence condition. So we will copy a new line here. So we will use the camera busy signal turn on. Once it's turned on, we can move to the next step, control this step condition, control this sequence condition. And this time we could set very short, for example, 20 milliseconds. This timer should be shorter than the actual processing time from your IV sensor. And once we got this busy turn on, we can shift to the next step. And once we shift to the next step, this trigger signal will be off. Okay, so the step will move to the step 5. At this step, step 5, we will stay in this step 5 till the busy signal shift from on to off, and then we shift to the next step. That means at step 5, we are waiting for the busy to be 0 to move to the next step. So at here, we will use the busy from 1 to off. Once it's got off, once this busy signal from on to off, that means the camera results can be registered by the PLC. So once the busy signal is off, so we can move to the next step. It controls this sequence condition. And this time, we could also set a very short. And it moved to the number 10. Okay. So once it got a number 10, we can register the camera result. So at this step, I will create one branch level and create output. So this tag we can call the camera register. Okay, so this is the temporary tag we will use. Okay, create here. Okay, and at the step 10, so we need to basically wait for one entire cycle in the PLC, and this register signal will be used as a command signal to register the camera results. So at here, I will set, so make it turn on, for example, 15 milliseconds. Make sure it turn on entire one cycle. And which signal will turn this sequence condition 10 to on. So basically, once we reach here, we can turn it on. Also, we could use this busy, non-busy signal to turn it on. So at here, we can add a branch, use this not busy signal, and turn this sequence number. Okay. And now we reach to the step 15. At the step 15, actually we already reached the end. So at this step, basically the timer we can set 0 without any stop here. And this sequence condition can be always on. So we can delete this sequence condition, or we can do this way. So at a branch level, and directly turn this on. So we can use this OTE here. Okay, and at the end of this 15, we can move to the entire sequence to 0. So we can set 0, go back to 0. Okay, so we can delete this step. So 15 will be the last step. Okay, and for the timing out, if there's a process not equal to 0, and if the sensor has an error, we can move to the entire sequence number to 0. So we will use the camera error signal at here. So we can use this condition at here. So the camera error signal. So we can use this camera error signal. So if the camera has an error and our sequence stuck somewhere, so we could wait for maybe 10 seconds. And after 10 seconds, this sequence start. So if the camera has an error, we will reset this sequence number. Or here, if the camera keep busy, that means the camera probably stuck or totally busy, no response anymore. So we can also move to the step number, go to 0. So we could also use a busy signal. In normal status, most of the cases, the camera will use just 100 milliseconds. If the processing greater than 2 seconds, that means the camera could have something wrong here, unless the camera is taking one complex inspection task there. From the demonstration wheel, I will set 10 seconds here as a watchdog if the camera got a timeout, so we will send this sequence to 0. Okay, the 15th step, that is the end of this sequence step. So I will change this to 15. Once we reach the step 15, so we turn on this complete. So till here, we complete the entire sequence here. And probably we could also use this arrow signal, move to the top. So at the beginning, the camera shouldn't be busy and shouldn't have the arrow, and then we trigger the camera. Okay, so let's compile and download. Download. Okay, firstly let's check out this connection here. So now it shows this triangle here. That means the communication is not correct. I haven't set up the Ethernet IP connection into the camera side. And we need to set something from the camera side. So let's shift to the IV2 camera side. So from the IV2, we need to use the IV2 navigator. Use this network connection. And since the IP address of this IV2 amplifier, the IP is 192.168.1.101. So type in this IP address, click this connect. So this camera is used to check this housing and this pieces present on this housing. Okay, so now this camera, we need to shift to the programming mode. And firstly, let's check out this sensor setup. Check out the trigger need to be set to external. Allows the PLC to trigger this camera. Okay, and from this camera, we set up 3 parts, part 1, part 2, part 3, 3 tools here. Check 1, 2, 3, these 3 pieces here. Okay, this is a quickly review. And then we need to go to this advanced setting. And we need to check out the IP address setting. So this IP address is 1.101. Okay, no problem. And then let's go to the utility. We need to set this field net, this communication, to Ethernet IP. So, and protocol, we need to shift to the Ethernet IP. And there will be 2 ways. One way is using the handshake. Another way is without handshake. For normal use, we will use this disable handshake. Okay, so click OK. After click this OK, the camera probably need a half minute to reboot itself internally. So meantime, there will be no response. Okay, so we basically finished this setting from this IV2 side. Let's shift to the PLC side. So you see, we drop the connection. The camera is rebooting itself. And now we can go back to the PLC side and watch this status. Double click and watch this status here. So we can see now it's showing the running. That means the Ethernet communication is correct now. Everything shows good. Now the camera is in running mode and is ready, not busy and no error. And if we present the part, once we turn this on, the sequence will start. Okay, so I will reorganize the direction of the part, and let's see if the camera can be triggered. So watch this step number here. Turn on. Which is very fast. So actually it's triggered. So if we shift back to the camera side, so we can see it actually got triggered and give the correct result. Okay. Now you will have a question, how we can use the PLC to register the camera result and how we can pick the individual tools from this communication. Okay, let me introduce how we can register the result. Now the communication are correct and the camera got this trigger correctly. Okay. So if we review this controller tags, the results from the camera, the results from the camera, we can check out the signal from this IV2 camera to PLC. And the inspection result, overall judgment, now that is on. That means the recent inspection that is passed. That is the same as we saw. And the individual tool, we can check from this tag, the tool 1, tool 2, tool 3. Those three tools are on. So review this camera. That index number is this to that tool 1, 2, 3. And now if I present one bad part and use the PLC to trigger. So let's reload the part present, and let's trigger. Okay, if we go back to the camera side, we will see this is one bad part. It got a trigger, and this tool 1 is failed because this part lost. So go back to the PLC side, go back to the tag. So we will see the tool 1 now is a 0. 2 and 3, they are on. That means the tool 1 failed. You can imagine we can use this individual tag to show the indicator on the HMI or show the indicator. Basically tell the operator one part lost on this entire production. Okay, and meantime, this overall judgment is 0 because it failed. And those signal comes from the sensor direct. How we can use this logic to register this result? If you recall, from the step 10, we have a signal that is a camera result register command. So using this register result and involve the camera actual signal feedback, we can register the result into our PLC internal tag. So at the end of the program, we can use this way at run and use this camera result register command. And it will turn on 50 milliseconds. We will register that result within a short time in case the camera signal got a toggling or got a flickering, right? So the actual result we need to read from the camera. For example, the camera entire result. So this is the overall judgment. And this is the signal direct from the camera. And here we will latch in this result. So here we will create another tag that is a IV2 inspection. So create this tag. And when we need to reset this signal, and basically once this part present gone, so we need to reset this inspection result, right? So we need to create another line, use this. If this part present disappear, okay, so we will reset this result. Okay. So after we add this logic, basically for each part, we need to monitor this tag. When this tag turn on, that means this part is good. When this part fail, that means this part got something wrong here. So let me trigger again. Now I reload a new part. Okay, let's turn on this part present and let's trigger this camera. Once it's got triggered, we will see at the end of this logic. So this signal turn on, that means this is a one good part. So if we shift to the camera side, so this is the one good part and the 3 pieces all good. Okay, and now I will load a bad part. Now I haven't triggered yet, so I reload a bad part. So from PLC side, I will reload that signal. Okay, so I will trigger the camera. You will see the camera will be triggered. Now it triggered, so the first part lost. And if we go back to the PLC side, and we will see the sequence got a complete, and this result, they are off. That means this part is failed. And in the meantime, if we go to browse this tool 1, 2, 3 result, this tool result, we will see the tool 1 is off, and 2 and 3 they on. So that means the problem comes from this tool 1 inspection tool. Alright, that is for today. In this video, I used the Rockwell Allen Bradley RS Logic 5000, used the compact Logix L32E, and use this sequence structure to trigger and register the camera result. Our camera is IV2 camera, and we are using the generic file, and generic setting is here. Also, we use this UDT, set up the tag name, and create the tag. And from this main program, we image the actual input and the output image to the PLC internal tag. And in this IV2 camera, we are using the structure, and the structure is based on this timing chart, and we separate this timing chart into different steps. And based on this step number, we use this actual signal from and to the camera to trigger the IV2 camera and register the camera result. And this sequence camera trigger and register structure can be also used for different brands, for example, Keyence, Omron, or Cognex camera. Also for some laser sensor, barcode reader, they are all commonly used. So you could use this structure as a reference for your different applications. Alright, thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.